Hi friends, welcome to the session on singularity of the function. The other name for singularity of the function is the singular points. Let us see this in detail now, right? First, let me define what is singular point or singularity. A point z is equal to a at which a function f of z fails to be analytic. Fails to be analytic is called singular point of the function. Is called singular point of the function f of z. So when you find a point at which the function fails to be analytic, right? So we know f of z is if f of z is an analytic function, the point at which the function fails to be analytic is known as singular point of the function. That means the point at which f of z is not defined. That point is known as singular points, right? So let us see this. F of z is equal to, let us assume f of z is equal to 1 by z minus 3. Here where the function is not defined, when z is equal to 3, it is not defined, because when z is equal to 3, the function becomes infinity, that is blows away. So z is equal to 3 is a singular point, right? Okay, let me take one more example. F of z is equal to e power 1 by z minus 3, right? Here also you see when z is equal to 3, the function blows away, because e power 1 by z is equal to 3 means e power 1 by 0, e power infinity is infinity. So z is equal to 3 is a singular point, right? So we may have some doubt as a EC student. You may have doubt. Then what is that? You are finding whether at what point the function f of z becomes infinity. It's like appearing. It's appearing like finding the pole. Yes, there is one difference between the pole and singularity. What is the thing is, you see the example number 2 here. Z is equal to 3 is a singular point, but it is not a pole, right? So what is the pole? Pole is a denominator. So we take f of z is a function, right? In that we should have numerator and denominator, right? For what value of some denominator, let us assume this is z minus z1, this is z minus z2. For what value of this z, the function becomes infinity is pole. That's what we bother about denominator. Here, at what value the function is not defined. What value of denominator variable the function is not defined is called pole. But here you see it is not bothering about denominator. At any location, if here you see if z is equal to 3, then the function blows away. That is f of z becomes infinity. That is a singular point, right? At this point, the function fails to become analytic. So you must understand, pole means we have to bother about denominator variable, whereas singular point, any place we can find singular point, right? Pole is bothering about only denominator. We have to consider denominator. At what value of the denominator, then denominator variable, the function blows away. Here, any location at what value of the variable at any location, the function blows away is called singular point, right? That is the main difference between this one. But here z is equal to 3 is a singular point. At the same time, it is also a pole, right? That is the difference. That's what I have taken this example. Okay, there are some different types of singularities. One is isolated singularity, right? So what do you mean by isolated singularity? The isolated singularity means a point z is equal to a is said to be isolated singularity, provided, what is the condition? 1, z is equal to a must be a singular point. whatever. First z is equal to a must be singular point. Second condition, in the neighborhood of z is equal to a, in the neighborhood of z is equal to a, the neighborhood of z is equal to a should not contain any singular points, any other singular point. So a point z is equal to a is said to be isolated singular. First it must be singular, then in the neighborhood there must not be any other singular point. For example, let us take this problem. F of z is equal to 1 by z minus 2 whole square. Here what is the singular point? Z is equal to 2 is a singular point, because when z is equal to 2 the function is not defined, that is it is becoming infinity. So z is equal to 2 is a singular point, and nearby that there is no other singular point. It is the first, it is singular, and neighborhood contains and no other singular point near to. Neighborhood contains no singular point. So it is isolated singular. So z is equal to 2 is a isolated singularity. That is very important, right? So z is equal to 2 is isolated singularity, right? So this is the example. Like that we can find. Okay, then we will see one more different type. Removable singularity. Removable singularity. What about removable singularity? Removable singularity means a point z is equal to a is removable singularity is called, right? RS is nothing but removable singularity. A point z is equal to a is called removable singularity of f of z if, first thing as usual, z is equal to a must be a singular point, right? Second condition, limit z tends to a, f of z must exist, right? So let us see one example. For example, let us take f of z is equal to sine z divided by z, right? So first condition, what is singular point? Z is equal to 0 is a singular point. First condition is valid, because when z is equal to 0 the function becomes infinity and not defined. Second condition, limit z tends to a is singular point, limit z tends to 0, f of z is sin z divided by z must exist. We know limit z tends to 0, sin z by z is equal to 1, it is existing. So from this we can say z is equal to 0 is a removable singularity, right? Okay, let me give one more example. F of z is equal to z squared minus 2 square divided by z minus 2, right? Let us see first problem. First find the singularity point. Singularity point is z is equal to 2. When z is equal to 2 the function blows away. So z is equal to 0 is singular point, and we have to see whether this singular point, the limit exists at this singular point. Limit z tends to 2, f of z. F of z is nothing but this one. So this I write as z squared minus 2 squared divided by z minus 2. This is the second condition, right? Limit z tends to a is 2 for us, f of z is what do you call it, z squared minus 2 squared by z minus 2. Z square minus 2 square divided by z minus 2 is z plus 2, because z minus 2 plus into z minus 2, cancel it, it will become z plus 2, that is equal to 4. Z is equal to 2 means it will become 4, so exist. So z is equal to 0 is a removable singularity, right? So this is very important point. This is removable singularity. There is one more singularity called what do you call essential singularity. Essential singularity means, as usual, a point z is equal to a is called essential singular. First condition is z is equal to a must be a singular point. Second condition, z is equal to a should not be a pole. It must only be singular point. It should not be a pole, or it must be a removable singularity. Right? Okay. Already I have given the example. Your point must be singular, but it should not be a pole. You remember this? E power 1 minus z minus 4. Let us take, what is a singular point? First point is z is equal to 4 is a singular point. Because when z is equal to 4, the function becomes infinity and it is undefined. Right? But z is equal to 4 is not a pole because it is not bothering about denominator. So z is equal to 4 is not a pole. This indicates z is equal to 4 is a essential singularity. Essential singular point. Right? This we remember. Okay. Similarly, another example, f of z is equal to sine 1 by z minus 2. Right? Let us take this example. You see 1. First condition, find the singular point. Z is equal to 2 is a singular point because when z is equal to 0, sine 1 by 0, sine infinity, singular point. And second condition, z is equal to 2 is not a pole. It is not bothering about the denominator variable. Is not a pole. So z is equal to 2 is a essential singularity. I hope understand the singularity very clearly. If you have any doubt, please ask me in comment section. I will clarify. Thank you.